So 5-6, last section on vectors. And today we're going to look at extending vectors into 3D. So when we do things in 3D, you still have an x-axis and a y-axis, but you're just going to add in the z-axis. And the way you can figure out like, which axis goes in which direction, this is called a right-handed coordinate system. That's what our book refers to it as. So right-handed coordinate system means if your index finger points in the x, middle finger is the y, then your thumb is the z. Those are the three directions. If you do that with your left hand, and you line up the x and the y, the z is backwards. Okay? So, yeah. So, if x is towards you and y is towards the door, then z is the ceiling.
Wait. How do I make one up?
What?
How did you do that?
Well, if you line them up,
Like this?
if you line them up with your left hand, then z points the wrong way. Points down instead of up.
Is this right, bro?
Okay, so each formula that we do, it's basically I'm going to show you the 2D version, and then I'm going to extend it to the 3D version. Okay.
Oh, I put down homework for this, and I was very confused.
So in 2D, that's your formula for finding the distance between 2 points. Okay. Technically, that formula is not it's not a vector formula. Okay. It's the only formula today we're going to look at that is just about a point and finding how far apart they are. D stands for distance.
Wait, is this a new formula?
No, it should not be a new formula. Okay, so you should already know that formula from geometry or something you did
Wait,
earlier.
is this distance formula?
That's the distance formula.
I do know this formula.
Yep.
And what does this define? Wait. Never mind.
So now, when we extend that formula for 3D, we just have to add one more piece onto the end underneath the square root.
I have a question.
What do you think we're going to add?
X over Z. Z2
yep.
minus Z1 squared.
Squared. Okay, so every formula that we do today, all you have to do is look at the pattern you already have, and then extend that pattern one more time for the z's.
So when you're measuring like a line that in 3D space, how does that change it? Isn't it still the same length for finding the distance between the points? Like what? So like you have a line in our 3D plane. How does the distance from here to here change, whether it's 2D or 3D?
Because you have to do Pythagorean theorem twice.
But why? No, a line has no width.
If you look at this, it looks like it's 4, but if it's farther back,
That doesn't change the distance.
It looks
It changes
like-
your perspective.
So if you had let me show you a picture. Hold on. So if you wanted to find the distance in 3D, right? Let's say you wanted to find from the back left on the bottom of that box to the front right top. Okay, so you're going across the diagonal of the box.
But how's that going to change whether it's 3D or 2D?
So in order to find that distance, if I tell you this, and that,
Yes.
that's the length of the box, the width of the box,
Oh wait,
and
so
the height
are
of the
we just
box.
finding a side of a pyramid?
So the first thing you have to do, if you want to find, if you want to find the distance between those 2 points,
Yeah.
is you need to find the diagonal distance across the bottom of the box. Okay?
Wouldn't that be the same?
So this is a right triangle right here.
Yes.
Doesn't look like a right triangle, but it is a right triangle because it's the 2 sides of a cube, and then it's the diagonal across the bottom. Once you know the diagonal across the bottom, then you can do another triangle like that.
But wouldn't C and E
That purple one is
equal
your,
if it's a square?
no,
If it,
nope. C is across the bottom of the box.
E's the hypotenuse.
He's going up.
E is going from the back left bottom to the front right top.
oh, I see.
E is 3D.
Okay, but
So the reason why you need that extra,
yeah.
the reason why you need that extra part in the formula is because the first part gives you the length across there. That's the Pythagorean theorem with A and B. And then This is the Pythagorean theorem again, and that's a 90 right there to find E.
Okay, so where did the
I have a
vector
question.
go?
So where did what?
Where did the vector go?
This, I told you this formula is not about a vector.
I have a question.
Yeah, this problem is about just two 3D points.
To find the side lengths of a pyramid, are they all equal?
Yeah, it depends on the kind of pyramid, no.
Like square bottom come to a point, four sides?
All the edges might not be the same in a pyramid, like if it was a really tall and skinny pyramid. Like kind of a really tiny base. So then the sides of the base could be real short, but then it could go up very tall.
Yeah, but all the ones going up are the same.
Yeah.
So could you just do that with here? Because it's got a square base and it's got all these sides?
Yeah, that's basically what you're doing. It's like the side of a
Yeah.
pyramid. Yeah. Yeah.
I don't know what I was gonna say.
So could we use the formula to, I don't even know, is there a formula for that?
If you know a different formula, yeah, you could use one.
I don't.
But I'm going to be giving you the problem with coordinates. So you're going to know an x, a y, and a z, and you're going to find the distance between the two.
Oh, so like x, y, wait, so P1, that's a triangle, P2 is the second triangle?
Just input points into the.
So no, these aren't triangles, these are coordinates.
Oh,
According to the 3D space.
Yeah, it's a 3D coordinate.
Look at that, I'm learning.
So the x is -1, the y is 3, the z is 2. And then in this one, the x is 4, the y is -2, the z is 5. So you've got to take your two coordinates, fill them into the distance formula in 3D,
yes.
and then solve.
So when you say in 3D, that just means this formula?
Yeah, I mean, this is the 3D version of the distance formula. If you
Okay.
take off the z's, you're only doing the 2D version.
What would you do in the fourth dimension?
We're not going to talk about the fourth dimension.
Can you do 4D math?
It depends on how you define it.
What is the D?
Have you seen like,
Why, what do you think?
Okay, so what is,
Dimension.
what's x1
x1 is -1,
and y1
y3, it's 3.
D.
and y2?
2. Wait, why does that not?
I'm sorry, I meant z1.
That's 2.
Z1.
Z1 is 2.
Okay, so those are your three x1, y1, and z1, three parts of the first coordinate. What's the 4 going to be?
X2.
The x2 and the -2
Y2.
and the 5,
X2. Z2.
z2. So now you're just filling in those 6 numbers and see what we get.
This isn't too bad.
Okay, what's going to go in the first parentheses?
-1 minus 4.
Or -1, -1, plus
4 plus
4 minus -1. And what do we have to do with it?
Square it.
Square it. What goes in the second step?
Y1 and Y2. So -2
y2 minus y1.
-2
Minus
minus 3 in parentheses and then square.
And what about the third step?
And then you have to put 5 minus 2 in parentheses and square.
Okay, so what's 4 minus -1?
5.
And when you square it,
25.
I have an additional question.
25. What's -2 minus 3?
-5.
So it would be 25.
25 again. And what's 5 minus 2?
3.
So 9.
So 9.
So 9. So what's the distance between those 2 points? Square root of 59. Yep.
Yes.
Yes.
At the end of class, because I remember you were explaining the negative numbers things, but you did it without numbers. Because like 4 minus -1 just, or minus -1 just makes no sense to me. Like I know it equals 5, but like.
Yeah,
why
if we
would-
have time, I had looked it up. I'll have to look it up again because I
Thank
don't
you, Mr.
remember.
Hager.
I don't remember.
Taking away.
Yeah.
Do you want us to are we supposed to simplify the final answer again?
So if it says to round it to a decimal, then yeah, you can. If it says leave it exact, you leave it just like that.
Do we do the thing where we split it up?
But you can't
Like, say if it's
simplify
like
59.
Yeah, if you had like the square root of 20, yeah, you should do like 2 square root 5. Yeah. Okay, so that's the only formula we're doing today that is not vector. Okay, it's a 3D formula, but it's an easy one, so that's just kind of like a,
Would you say the other ones are the same?
just to get us used to working in 3D. Okay. Now we're going to work with vectors in 3D.
Oh.
So, in 2D, how many components does a vector have?
It has a line and then an arrow, right?
So how many components would be a number?
2.
2. What are the 2 components?
The line and the arrow. Oh, okay.
And those represent the,
The magnitude and
Left
Length and height.
so components are directions.
up and
Up
down.
and down.
right.
So yeah,
Up and right.
horizontal and vertical.
Yes.
So in 2D, you have horizontal and you have vertical. Those
And
are
now you
only
have,
2 directions.
so what do you get away
When we talk about 3D, I'm not going to use horizontal and vertical because it doesn't, depending on how you're looking at it in 3D, horizontal and vertical don't
Are they
don't
just
make
like
sense.
subjective?
Yeah. So in 3D, we have to add another unit vector. Okay, we already have I. That's 1 unit pointing in the x direction. So if you want to imagine the board, like if the board is the xy plane, so x-axis, y-axis, z-axis is coming at you. So I would point left and right. J would be the up and the down. And the K would be the unit vector that points out of the board or into the board, depending on
So towards and away?
which way you're going. Again, if you imagine your axes being like that. This is the XY axis. That's the Z
Is A, B,
axis.
and C just like placeholders
Yeah.
for letter numbers?
So the A, the B, and the C, those are the components of the vector. Those would be numbers in a problem.
With the K, which way would be positive and which way would be negative?
If you're looking at it like you have a table in front of you, I would view the Z as coming up from the table, and the negative Z is going down into the table.
Wait,
If you had a
I
table.
thought that was this way.
Yeah, so if you had a table in front of you, your desk is the XY, and the Z is coming off your desk. Positive, and into your desk is the negative. So the A, the B, and the C, those are the components. Okay. This, again, I'm not going to say horizontal and vertical. I'll say the x-axis, y-axis, or z-axis component. Those are the 3.
Which one's your favorite?
Z.
Why?
It's just more fun.
Because it's at the end of the alphabet.
Okay, so any question on
You
that?
said components of the vector, so that's just like the horizontal thing, the vertical thing, and the towards and away thing?
Right. I'm not going to draw it in 3D, but if I was doing it in 2D, that's a 2D vector. This is the horizontal component of the vector.
Kind of like the slope?
That's the vertical component.
I get it.
Okay. So these 2 arrows combined together make the one in black. In 3D, you would have 3 arrows combined together to make the one in black. Okay. A vector that starts at the origin is called a position vector. So we had that already in our notes on Monday. It's the same thing. Vector that starts at the origin is called a position vector. This notation does not tell you where to start from. So if I say to draw the vector, and I give you something like that, you can draw it anywhere you want. But if it starts at the origin, then it's a position vector. Okay, so next I'm going to review how you find a position vector in 2D, and then we'll do the position vector in 3D. So that's the formula for a position vector in 2D. You're going to be given the x's and the y's. In 2D, they're going to tell you where it starts and where it stops. When you find the position vector, you subtract them. Does the order matter?
Yes.
Yes. Has to be terminal minus initial. Now, to do a position vector in 3D, instead of giving you coordinates like that, we give you coordinates like each coordinate is going to have a 3D part to it. What do you think the formula is going to have in 3D added on to what we already have right there? So what do you think? What do you think you're going to have to put onto that formula to make it 3D? Z
squared and not, I mean, Z1, Z2.
Z1 minus Z2?
No. The other way around.
Other way around. Yeah, Z2 minus Z1. So when we want to write it in 3D, it's exactly the same formula as 2D, except now you have the Z part added onto it.
And this is for a position.
That's how you find a position vector in 3D. 3D. All right, so let me give you a point, and let's see if you can find the position vector.
I'm ready.
So-
Find the position vector.
P1 is negative 1, 2, 3.
You do 4 minus minus 1.
Okay, so you're going to do 4 minus
Which is
minus
5.
1.
Good job. Okay, and then you do 6 minus 2. And then you do 2 minus 3. Which is 5.
And what is that vector?
That's a position vector.
And what would it actually be?
Oh, it would be 5, 4,
3, 2,
no. Okay, wait. Negative 1.
Negative 1. Okay, so that's one way you can write it. Or how about with the I, J, and K?
5i plus 4j minus 1k.
Yep. So
And what's that
either,
called again?
that's called unit vector notation right there. Because it uses I, J, and K. So either answer is correct. It's just a matter of what format they ask you to write it. Okay. Any question on finding a position vector in 3D?
How many questions are going to be on the test tomorrow?
Probably like 16, 17 questions.
I'll give you a high five per question. Can I get 100?
Possibly if you would like to, sure. Okay. So one thing that we did a lot in 2D was we sketched things, right? We took one vector, added another vector visually. You can do the same thing in 3D, but sketching it in 3D it's a little harder. So we're not going to be sketching in 3D. We're going to go right to adding, subtracting, and scaling, just using the numbers. Okay, no visual.
Is it all like done in the same way?
It's all done the same way. Yep.
So it's kind of like a review day.
Yep. So if you wanted to add two vectors together in 2D, that is how you would do it. You'd take the x components of each vector, add them
Why
up.
does it say plus or minus?
Well, you can
Oh,
add or
it's
subtract.
negative?
Well, add or subtract.
So like if it's negative, it'd be subtracting.
Yeah.
You're subtracting.
Multiplication.
So if you're going to add these vectors, you do x1 plus x2. You do y1 plus y2. And that would be it for 2D.
Yeah.
What do you think we have for 3D now?
Z.
Z,
Yellow.
Yellow.
yeah,
blue.
z1 plus z2.
Correct.
If you're subtracting the vectors in 2D, x1 minus x2,
I get it now.
y1 minus y2, and you're done. If you're doing it in 3D, you have one more step, z1 minus z2. So that's adding or subtracting in 3D. Okay. What do we call a number in front of a vector?
A scalar.
A scalar, yep. And when you do a scalar product,
You multiply.
yeah, it's like you multiply it out to each part. If you were doing 2D, all you'd have to do is multiply that number to the x and then to the y.
And then to the Z.
But now we're doing 3D, so you got to do it one more time.
To the Z.
This isn't bad, this is like.
It's like a review day.
So every formula we've done before, it's the same thing, except you're just adding on one more part for the z. And it's the same pattern that you had before. Okay, what is that symbol?
Magnitude.
Magnitude. Okay. How do you find magnitude in 2D?
That is a good. Pythagorean
Pythagorean theorem, but we're just gonna add
x
Z.
squared plus y Pythagorean
Okay.
theorem.
So in 2D, you do x squared plus y squared. But now we're in 3D, we need one more part.
Plus z squared.
Yep.
Oh, you're good.
So when someone said Pythagorean theorem, yes, this is the Pythagorean theorem, but
With a
it's
Z.
in 3D. So instead of just being like on the floor, it's coming up off the floor.
So it's like standing up.
Yeah,
I see.
yep. So
But not
before you were
really
finding
shaped.
Pythagorean theorem of things that were always flat on the
Now
desk.
it's like this.
Now it's tilted off the desk, and you're using Pythagorean theorem.
How does that change it?
Because you have to do Pythagorean theorem twice.
But it's still, well, I get, okay.
Yeah.
So like, what's the difference between doing Pythagorean theorem like a triangle like down and a triangle standing up? Because it's not losing or gaining anything, is it not?
Well, in 3D, I gotta find, like if I had a box on my desk,
But it's not 3D shaped, is it?
yeah, well, it's in 3D space. Yeah.
But the but I thought like when you try to find the area, like the flat triangle, that it like doesn't have any width, so it's not 3-dimensional.
Like let's say you wanted to find,
Wait, can you have 3-dimensional? Wait, can you have 2-dimensional shapes in a 3-dimensional plane?
yeah, think of like a piece of paper.
Yeah, that's
This
what
is
I'm thinking about.
pretty 2D. I mean, it's just has length and width, it has no thickness.
Yeah, so you have a piece of paper and you stand it up, but it doesn't change anything.
So if you wanted to find, let's say this was standing up off of that, and you wanted to find like the distance from, it's kind of hard to do in 3D, but let's say you had a point out here, and you want to find the distance from this point to this point.
Yes.
The first thing you have to do is figure out this distance, right? Because you need that if you're going to make a triangle in 3D.
Yes.
So now you have this point, and then the point floating in front,
Yeah.
and you can make a right triangle.
Yeah.
Now if you know this and this, to find this you need Pythagorean theorem. But then to find the point out here, you're going to use this, this, and then Pythagorean theorem again. So it's Pythagorean theorem twice.
I kind of get it though.
It's just in 3D. All right, so let's take these two vectors and add them up.
Okay, I'm ready.
Since they gave us the vectors as unit vectors, we're going to write our answer the same way.
So it'll be 5i,
So when we add them up, we get 5i.
and then -1j,
You can do -1j or just -j.
and then 3k
And what do you need in front of
plus
that?
3k.
Yep. So that's how you add those two vectors up in 3D. Any question on that?
No.
All right, let's try scaling.
Are we gonna have to do those velocity things in 3D?
We'll do scaling now. Let's do magnitude next. Velocity in 3D, no.
Because that was, I was struggling.
Okay. What's the first thing you write down to find the magnitude?
You do square
Square root.
and then you put in there 2 squared plus 3 squared minus 2 squared.
So it's always plus,
Now plus -2 squared.
which is
Um,
4.
And then you add them.
So yep, 4, 9,
17.
4. 4 and 9 is, yeah, it's going to add up to 17.
Square root of 17.
And just like somebody asked before, should you reduce it? Yep, you can. Otherwise, just leave it like that. Okay. And how about part C? 3w.
Okay.
Okay, what's 3w going to be?
Are we what are we doing?
Multiply.
That's a scalar product.
You 3, 6, 7, 8, 9. 9i.
9i
4, 8, 12. -12j.
and -12j
And then 15 plus 15k.
plus 15k. So if you were drawing that vector and it was on the board, that's 9 to the right, it's 12 down, and then it's 15
Out.
towards you. So that would be the vector coming
So it'd
out
be
at
like-
you. Yep. So if it's started over here and then it's coming like down that way.
I see.
Yep. Okay. Any question on that one?
No.
So that's adding, subtracting, and scaling in 3D. Okay, dot product in 3D. Well, what was our dot product if I had something like, let's say, 2i plus 4j and negative 5i plus 5j? How do you find the dot product between these two?
9, 1, 1,
Wouldn't it be 2 cosine?
Wait, what?
So no
No.
sine or cosine in dot product.
Oh, wait. So you do 2i times negative 5i.
Just 2 and negative 5.
Yeah. Plus, you add 4 plus 5
No,
times 5.
And that would give you a dot product of how much?
20, 10.
10. Yep. So that's how you do dot product in 2D. Now we're going to look at dot product in 3D. Okay, so in 3D, instead of just having an x and a y, you're also going to have
Z.
the z. So here's your formula for 2D. Multiply the x's, multiply the y's, add them up. What's the one more thing we're going to have to add onto the end?
Z.
Z,
Z1 times Z2.
z1 times z2. Yep. And that's going to give you the dot product in 3D.
Okay, 1 second.
So let's find the dot product between those two vectors.
Okay. 5 times 2. Right. 10.
So what order, if we want to do v dot w, it should be in what order?
2 times 5.
2 times 5.
And then negative 3 times 3.
Negative 3 times 3.
And then 6 times negative 1.
6 times negative 1. Okay, what's 2 times 5?
10.
10. So I don't have to rewrite the whole thing, I'm just going to put it above it. What's negative 3 times 3?
Negative 9.
And 6 times negative 1?
Negative 6.
Okay.
Are you going to throw some like crazy numbers into these and we have to do them on the test? Like some like crazy square.
Well, you could use a
fraction?
calculator for any numbers, so.
Okay.
What's 10 minus 9?
1
So that's 1
minus 6.
minus
Negative
6.
5.
And the dot product is negative 5.
Yay.
Any question on dot product in 3D?
No.
Okay, what did we use the dot product to figure out?
The multiplying.
What goes on the bottom, like the thing?
So the dot product was part of a bigger formula.
Yeah, I don't remember.
What
The
was-
second half was really confusing. I only understood the first half.
What was that bigger formula used to calculate? Okay, does anybody remember what was the last thing we did yesterday?
It was very confusing.
What we used the dot product for?
The standard formula after it.
Was it like the wrong?
Oh, isn't it finding
Finding the
parallel?
angle.
Finding the angle, yeah.
Belly trap.
So we're going to do the same thing in 3D. So in 3D, if you want to find the angle between two vectors, first I'll give you two vectors that are 3D. Then we have to use that formula. Okay. How does that formula look different from yesterday?
There's 2. Wait, they're flipped too. Wait, no.
I don't know. What's
There's
the
2.
same?
There's 2 of like the magnitudes.
There was 2 in the
There
magnitude.
was?
Yes.
There were two magnitudes yesterday, yeah.
I'm confused.
Was it V times U? I don't really know what
The letters you use, I mean, you could use A and B. That doesn't matter.
there's no thing before cosine or after it.
Was there anything before cosine yesterday?
I
Oh,
think
so.
maybe.
No.
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 Is
Is
it
it because
something
there's
else?
no I next to
cosine theta I?
No.
No, not in that formula. You're thinking of a
It looks the
below.
same.
Was
It
it
looks,
parentheses?
it looks the same.
Oh,
yeah.
so we're looking for nothing.
This formula is exactly the same formula as yesterday. So if you're like, well, how come it's not different? Every other formula when we did 3D, it changed a little bit.
Because
Well,
we had to add them all up.
that's because this is a 3D dot product, and we already changed the formula right here. So that's the new way we're doing dot product.
Oh.
And then it's a 3D magnitude, but we already changed that formula right here. We already added the z component into the
So
formula.
it's kind of just like a secondary part.
Yep. So it's, the formula is exactly the same.
I was a little bit lost yesterday.
U and V is like the
product of-
those.
So in the numerator, that's the dot product. In the denominator, it's the product of magnitude u, magnitude v.
Okay, wait. So, can you scroll back up for just a second?
Yeah, and I'm going to use the same two vectors we did before because we already have part of it done.
Okay.
So 2, -3, 6.
So the dot product is -5.
Yep, and just make sure they're the same. 5, 3, -1. 5, 3, -1. Yes, they are the same. So we've already got the dot product.
So u and v together is -5. I thought u or v was -5. I get it now.
Nope, the dot product is -5.
Okay.
Okay, now how do we find the magnitude of u?
Square root 2 squared
Which is
4
4.
plus 6
What's
plus
-3 squared?
9 plus 36.
Plus 36. What's 4 plus 9?
13.
And what's 13
49.
plus 36?
7.
So this is
True.
7.
7 times 7 is 49.
How about magnitude of v?
Square root 25 plus 9 plus 1 equals 10, 30, square root of 35.
Square root of 35, so
Simplifies
that's all you can
that.
do. Yeah. If it was square root 36, it would have simplified nicely, but it's not. So.
Is there a reason you could u and v if they look really similar?
They kind of do.
The u and the v?
Yeah, because like like when you draw u, it's not always like.
Mine U's always look like these.
Yeah, the u and the v could look a little similar. So no, maybe v and w would be better.
Yeah.
Yeah. Okay. Now, what's the formula that we have to fill
So now you have
those
to
three things
do
into?
-5 over square root of, over 7 times the square root of 5
I think I kinda got it.
Anything else?
or cosine theta equals.
Right. Make sure you put cosine theta because now you want to get rid of this.
Inverse cosine.
Inverse cosine.
Take the inverse cosine on each side. That's gone. And fill all of that into inverse cosine. Okay, when I fill it in, you tell me, how am I going to put that in?
Inverse cosine, and then
In
parentheses, and then another parenthesis if you want.
I don't need another one because the top is just a single
Okay,
number.
well then -5
Yep,
divided by parentheses.
now I do.
7 square root 35.
Yep, and if you don't put in that second parenthesis,
Yeah.
it won't work right.
I get it.
That's the correct answer.
Woohoo.
Let me show you what happens if you don't put in the second parenthesis. Let's get rid of that.
Oh wait, is there a way to just delete one thing? Because every time I just hit clear, it clears everything.
So first of all, when I try to type it in that way, it didn't even work.
I see.
So that actually would be the best case scenario. You try to do it, it doesn't work. The worst thing that could happen is somehow you try to type it in and you actually get, I'm trying to make something that would work. That's the worst thing that could happen is you type it in the wrong way and it actually still gives you a number so you think it's right.
How come the other ones did error, but no -1 didn't?
Because it was beyond 1 or -1.
Oh.
Yeah. So the correct way, I need to put that back, was like that. 96.93.
Wait, Wait, why does it have two parentheses on together?
Because you have to close the first one and then close the bigger one. So it's a parenthesis inside of another set of parentheses.
Because you have to do the 7 squared times the square root of 35 before you divide 5 or -5 by that.
Oh, okay, no, I didn't see the parenthesis after the divide.
Yeah.
How does that extra chromosome?
If you don't put in the extra parenthesis, this is what the calculator does. It does -5 divided by 7 times the square root of 35. That's not the same thing as that.
Okay, that makes sense.
It'll put the square root of 35 in the top, but you want to keep it in the bottom with the 7.
Yes, sir.
Okay, so that's the correct answer. Any questions on that?
Mr. Hager, I have a question.
Yes.
What's your favorite fruit?
Mangoes.
Mango?
That's a
That's
good
good
one.
choice.
I did not expect that.
My favorite fruit is pineapple.
Maybe actually
That's
skipping.
disgusting.
Okay, so that pretty much reviews everything that is going to be on the test for 3D, and it kind of went over everything again for
I
2D.
appreciate that.
Right.
Are we learning something new?
No, we're not doing, there is another product, remember I told you we learned dot product.
Please say we don't do cross product.
Yep, there's another one called cross product, but we're not doing the cross
Were
product.
we supposed to do it?
If we had time.
If we had more time, we would have done it, yeah.
I'm glad we're not doing this.
And then homework?
So that is the homework, and that has dot product on it already. So we're not gonna do
Okay.
a separate
Oh, we're
PDF.
not doing 2 different ones?
Nope,
Okay.
For what?
just one. Okay, so I will put a list of all the topics that are gonna be on the test right now.
I think it's 2, but.
Yeah.
Yeah, 2, 3 times. So like, how do we